Hey, good morning. Did you have your first coffee already?
I'm halfway through a bowl of cereal, so I'm calling that a win.
All right. Don't mind that because you're very much awake now, and we've had a whole day of discussions and presentations, so we are getting to see a little bit the shady sides of the different presentations. But we're still here and happy to see you, and thank you for joining in and making it. Um, whenever you're ready to go, we've had some intros putting a little bit of perspective on the state of play of the SBOMs. We've had many different discussions on new interesting technology developments for security for devices. We've had quite a long discussions on the Cyber Resilience Act, the one that's actually requiring SBOMs in Europe, and many other things. And we just had an introduction for many people for their first SBOMs, how to create them. So we've been using even a little bit the GitHub tools. So looking forward to hearing a bit of your experiences and also getting a bit of the perspective on why GitHub is doing what it's doing, and to get a bit of a perspective towards the future. So the floor is yours.
Absolutely. Thank you. I will share my screen briefly here.
Yeah, we can see it. However, I think we might have lost your voice. I don't know if that's the case. You can still hear me? Yeah, but we can't hear you again. That is strange. No?
All right. Can you hear me now?
Yes, perfectly. Loud and clear.
Okay. I think my microphone, I think I need a new USB cable for that, but we will sort that later. Okay. Great. So as I was starting to say, I don't know how much you caught before I tuned out. I am Justin Hutchings. I'm a senior director of product here at GitHub. I'm responsible for tools you may have used, you may love, you may hate, things like Dependabot, the dependency graph, and all of our capabilities around helping you use open source safely. I was asked to talk a little bit about software bill of materials today. I'm sure after a full day of activities, you've probably heard more about them today than you probably thought you ever would. But I've got a couple more perspectives that I wanted to bring to the table. So I think everybody probably saw SBOMs really come into the, public discussion a couple years ago when, as we were all sort of recovering from Log4j, we had the executive order on improving the nation's cybersecurity from the Biden administration, which made it a requirement for folks to produce SBOMs with software they sell to the United States government. And this got the ball rolling on a whole bunch of software bill of materials projects across, the entire planet. I would say, despite the regulation, what we've seen is most folks are trying to meet the regulation, but they are not yet focused on improving outcomes. And I got to thinking, what's the best way to think of this? And so I built sort of my own maturity life cycle on how people are producing SBOMs. And I made this up on my own. I didn't find one. Excuse me. I didn't find one that was already out there, so I built my own. But what's interesting is we've seen a lot of folks in this stage 0 that are maybe just creating SBOMs by hand for compliance with these regulations. They know that they are required to have them. They are not confident on how to build a good one, so they are building them by hand. And then they probably do not have any way to store or catalog or maintain these. And then they probably have no vulnerability data whatsoever to understand the impact of the software that they're delivering. Fortunately, I think the state of the regulations have driven most people beyond stage 0, towards what I'll say is stage 1, where you're creating SBOMs with automation. You probably still don't have SBOM storage, and maybe you're using some vulnerability data like the NVD, but it's really immature. And I'll talk more about what that actually means a little later in the talk. As you go up the stages, the things that start to change. So in stage 2, we see companies start to persist and catalog all of their SBOMs. That means you have a system for how you maintain the SBOMs for every release that you've ever cut, how you can catalog and query those to figure out whether or not there are patches required for releases that you've already made, and using a curated vulnerability data source so that you can go and monitor those with confidence. Usually this means you actually have people on staff that are responsible for reviewing the NVD and providing curated data, but it also might mean that you've paid an outside vendor that does this. And stage 3, I would reckon there are probably fewer than 100 companies on the planet that are at stage 3. So I drew a distinction on SBOMs being automatically packaged, and I'll tell you what that means. When we see most organizations creating SBOMs with automation, they're doing so at a code artifact level, not at a product level. In fact, even GitHub's own SBOM support creates your SBOM at a repository level, because that's the unit of work that we understand. But to produce something like, if you are buying a product like Microsoft Windows, you don't care about, okay, I have an SBOM for this print driver or this graphics driver. You want an SBOM for Windows, the entire thing. And to do that, you have to actually package many, many SBOMs and build a deep relationship hierarchy between many components. This is a step that very few companies I have seen are actually going through, but it's where we ultimately need to get, is understanding the relationship between software components that build together for delivery, and then building our SBOMs the same way so that customers have a chance at actually understanding what's going on. The other capability that I see in these very advanced customers is that they have their SBOMs cataloged and discoverable for customers with VEX information. And VEX is vulnerability exchange, which effectively is the human triage results of any vulnerability information that might be attached to the issues that are on an SBOM. And doing this requires a tremendous amount of process and organization to make sure that as new vulnerabilities come out, you are able to respond and tag all of your SBOMs in your historical catalog with whether you are affected by those vulnerabilities or not. So it requires a tremendous amount of work. This is not a, write it once and then forget about it. This is an ongoing process. And then finally, of course, you still need curated vulnerability data to get things done here. I don't know if we have audience participation sort of capabilities here, but I'm curious, having gone through this, among the attendees, what stage do you think your organization is at? If you're able to put something in the chat, I would love to know.
I'm looking around here a bit on attendees. My guess is we'll be at stage 0 and 1, and maybe
We're at 0, that's for sure.
But I don't think we've seen any with automation.
Fair. Okay, that's totally fair, and that's kind of what I expect from most of the people that I speak to. The folks that are at this stage 2 or 3, are really a very rare set of customers that have very deep relationships with a government entity that's driven them, and incredibly extensive compliance teams that can produce these assets. Okay, so I would be maybe a little bit remiss if I didn't mention, one of the elephants in the room on SBOMs, and this came up the minute people started talking about the regulations here. I remember actually reviewing some of the drafts of the guidance that was supposed to come out, and there was a big question at the time: will there be a recommendation on the format? And the government, the US government, sidestepped it. They described what are the minimum elements for a software bill of materials file, and they did not pick a winner in the format war. And I've included this funny XKCD comic here around standards and just sort of the way that they constantly proliferate, and we create more of them as an industry. So you might be wondering, well, which one should I pick? And the answer I'm going to give you is it doesn't matter. Any customer will be able to basically consume either of the formats. They are well known enough that you'll be able to find interoperability and make this work. In my opinion, the only reason you should pick one over the other is if there are scenarios that one supports the other does not, that are really important to you and your customers. Okay, so let's talk a little bit about how SBOMs actually get produced, for example, at GitHub. One of the things that you really need to understand for an SBOM is the set of dependencies that exist on your repository. In GitHub, we build a dependency graph in basically two ways. First, we have certain assets that we look at in your repositories that we scan automatically. We call these manifest files and lock files. Depending on the programming language ecosystem you use, you may not have lock files. But the example that I like to give is from the NPM ecosystem, where you have the package.json, which is your manifest file. It describes the direct dependencies you have and how they relate to each other. And then the lock file is the package lock.json. And that actually describes every resolved dependency that happened as a result of parsing that manifest. And we use both of them. The lock file ends up giving us the full transitive tree, however. And so that's the one that has more data, that provides more of the insights that we go and pull into the dependency graph. These all get built into a tree that's sort of based on a, repository has manifests have dependencies, and that's sort of the foundation for the SBOMs that we produce here at GitHub. We also have an interesting second category here, which is the SBOM file uploaded via API. And the way to think of this is there are certain types of software that do not drop a manifest file or a lock file that you can actually parse statically. One of the examples that I like to give for this category is Gradle. If you are a developer that uses Gradle as your build system, Gradle supports sort of arbitrarily complex configurations. It's Turing complete. You can build entire programs just in a Gradle build file. And so as a result, if you don't know the inputs into a Gradle build, you can't resolve the accurate set of dependencies on the other side. The example is, maybe you have one Gradle file that has a test configuration with a harness and a runner and a whole bunch of localization testing tools, and you have a production build. If you don't know the inputs, you'll end up producing an SBOM that may have a bunch of stuff that your customers are not going to see in their code. And so we rely on a thing. We have an API that we call the Dependency Submission API, which accepts simplified SBOM. We actually wanted to sort of not rely on people producing a full-on SPDX or CycloneDX formatted thing. So we came up with a very simple, very, very small API where they tell us about the API, the manifest dependencies that they resolved from doing this analysis. And this is a great extensibility point for the dependency graph overall, but it gives us that flexibility to deal with those ecosystems that aren't statically parsable. Okay, so once you've sort of set your repo up, you've got the dependency graph configured, you'll see if you go into the Insights tab and then the dependency graph, you will see a list of all of your dependencies. You will probably be horrified by how many there are. Quick statistic is the average NPM project has 10 direct dependencies, but that ends up resolving about 600 indirect dependencies or transitive dependencies. So you might think that your dependency graph is not very deep, but you will absolutely be surprised when you see this actually running. And then really importantly, we have support for an export SBOM button, and that will produce you an SPDX 2.3 file that you can go and use, and you can get that access on the API as well. So the push button export, as I said, is SPDX 2.3, and you can use the API for automatic export. One of the things that we see a lot of folks doing is using GitHub's releases API to implement that cataloging capability that I talked about earlier in the maturity model. So for example, when you have your release workflow run in GitHub Actions, we see people that are going and they build their release assets, they package their software for distribution, they call the SBOM API to go and get the SBOM for that release, they add it to the package, and they add all of those things to the releases API so that they can go later and query that repository for the releases and all of the SBOMs that are associated with them later on. So there are some challenges for secure software supply chain, however. I mentioned, one of the problems we have is with the quality of data on the NVD. So let's talk about that. First of all, I'll say, as a whole, CVE data is terrible. And what do I mean by that? They're not very machine readable. So if you went and looked at an arbitrary CVE, you would be surprised how little data there is to tie it back to a piece of software that a machine could identify. The example I always like to give is the library called Bootstrap. You'll often see CVEs, and I'm not picking on any of the projects named Bootstrap to be clear, but you'll often see a CVE that says something like, Bootstrap is vulnerable to, prototype pollution vulnerability. And you look at that and you go, okay, which Bootstrap? Because there are different projects named Bootstrap in many different languages. And so you get this CVE that's issued, and oftentimes there is no machine readable way to know which Bootstrap they're talking about. And so people often will go and just do a naive sort of comparison and end up with false positives because they can't tell what software it actually is supposed to be. We also see, and if you've been on LinkedIn or Twitter, you'll see lots of complaining about the exaggerated severities that we see. The number of CVSS 9.8 vulnerabilities has been going up, and this has led to a lack of trust in the data and the quality of the data because the NVD uses a worst case scenario scoring, which has led to a lot of inflation in scores. We also see that the descriptions are incredibly short. I did some analysis on this maybe a year or two ago and found that most CVEs are actually shorter than a tweet, which I think for the world's data on software vulnerabilities is far too short. We need to do better. Then a lot of organizations are starting to use reachability to figure out and prioritize the vulnerabilities that exist. All of that is proprietary. There is no reachability data on any CVE. The good news, however, is that there are public databases that you can use that do help. And, I'd like to toot our own horn. The GitHub Advisory Database is a great example. We have made that available under a permissive license. It's Creative Commons attribution. it has machine readable mappings, it has some reachability data. And so definitely go check out the advisory database as you're bootstrapping your own, data monitoring system to go and monitor the vulnerabilities on your CVEs, on your SBOMs. Okay. So let's talk more about software identity, because I think this is one of the big challenges that we see, both in secure supply chain overall, as well as in SBOMs, and it's the problem of software identity. If you've ever used a CPE, you're probably aware that CPE is terrible. The namespaces don't make a whole lot of sense. They're intended to be vendored, but they don't have a tremendous amount of clarity. When we were dealing with the Log4j incident a couple of years ago, I think this came, very clearly into focus, where people would see various vulnerabilities tagged as Log4j, and they were not clear on what Maven packages it actually impacted. And folks like GitHub had to go and follow up with the maintainers and follow up with various folks in the community to figure out which packages this actually was intended to target. The package URL specification is helping out quite a bit for things that are packaged and distributed centrally. But we still haven't seen that showing up in vulnerability data. I would encourage, we do with our SBOMs that are produced by GitHub, but I would encourage everyone that's minting SBOMs to actually look at using package URL to the extent you can. If you haven't seen one of these, it's basically a namespaced by the place that it's distributed. So, if you're talking about an npm package, you have a URL and it says it's npm bootstrap and then the version. And so it's very clear as to where it came from, what it's called, and the version, and it uses the same sort of naming semantics that the upstream registries use, which makes it incredibly easy for you as a person that knows where you got your software from to describe this in a reproducible way so that you can go and figure out that you're vulnerable to things. There is still more problems here in this space, which is around native code. If you use C or C++, most of the time that depends on hashing, because most of this code continues to be vendored today. The industry does not yet have a better solution for that. Or, if all of you know of a solution that I haven't heard about, I'd love to hear about it. But hashing is definitely a fragile solution. And so I know that there's interest in moving a lot of native code into package managers like VC Package or Conan to make this world a little better. I've been tracking the adoption of those. There's small adoption, but there's a lot of legacy projects that have to migrate before we can trust that native code is captured in SBOMs without doing hashing and lookups for those pieces of software. Okay. Other things that are challenges. So missing provenance. I don't know if folks in the room know what I mean by provenance, but the way you should think of this is, where did this software come from, and how can I verify that it's authentic? Today, not a whole lot of the ecosystems support any sort of provenance or signing so that you can tell where the thing came from. At GitHub, we did a release about a year ago where we added provenance to NPM, where if you build in GitHub Actions with a certain configuration flag, we will automatically sign that with a verifiable signature that ties back to the GitHub identity of the repository that did the build and the GitHub Actions workflow that specifically built it. This gives you the chance to basically validate that the software has not been hijacked. Hijacking is a process whereby, say I'm a maintainer of an open source project and I use tokens to go and upload copies of my software directly to a registry. If I lose the token, if someone steals it, if I put it on a registry or on a repo somewhere, someone could take that token and then pretend to be me. And there's no way to repudiate that the software that got uploaded was from the maintainer or not, because that one token is the entire identity that they provide for package uploads. And so the nice thing about moving to systems that are using provenance and signing based on the identity of the workflow that built them is that you can at least trust that the software came from the repo that the software is homed at, and you can go back and verify what the commits were that led to that release and make a judgment call based on that. That gives you a lot better repudiation as to the authenticity of the software. So definitely check that out. The last item I'm going to add here on provenance, which is a related but it's slightly tangential, which is malware. One of the challenges we see on malware are name squatting attacks. And so you'll often see, particularly internal packages, where attackers will create malicious software in a public registry and attempt to get enterprises to pick it up. So for example, let's say you work for SAP, and SAP has an authentication library that everybody internally uses. Looking at the SBOMs from a company like SAP, that even might show up in those SBOMs. And so people would, for various reasons, be able to discover that there's some library that's, I'm making this up, but like SAP auth helper. And that SAP auth helper name is something that you use internally to go and help out with authenticating between your apps and your backend. So one of the things that we see very commonly is attackers will discover the names of those internal pieces of software and then publish on public registries malicious copies of that software with the same name that are designed to do things like steal your Bitcoin wallet or look for other tokens in your system, or basically provide an opportunity for an attacker to go and breach a system. And there are two problems with this. One is, when we see that there's this malware in the public registries and we take it down, we mark it, we publish an advisory in GitHub for sure. In our advisory database, we publish malware takedowns from NPM. But the challenge is we're using a name that is not namespaced to say where it came from. So that, SAP auth helper library that we talked about, if I publish an advisory on that as malware, one of the things we definitely don't want is to tell people that are using the real copy that is authentic, that is distributed inside the environment. We don't want to tell those folks that they have a problem. We want to tell folks that might have picked up the copy that was in the public registry before it was identified as malware. Today, because we don't have provenance, we don't know when we're building an SBOM or reviewing an SBOM that software that's called SAP auth helper, we don't know if it's the authentic version or the inauthentic version, because all we have to go on is name. And that's a real risk that we have across the entire vulnerability and software supply chain ecosystem. What's worse is malware is not considered as eligible for CVEs. And so even when organizations like GitHub have this data, we have to publish it on a sideband to make that available to you. It is not part of the normal threat intelligence that every developer can receive and see through the NVD and CVE list. So lots of room for improvement there, but it's definitely a space that is actively being developed in terms of attackers building malware and defenders trying to detect it and take it down. All right. Well, with that, I know I gave you all a lot of information about the world of software bill of materials, what's going on across the threat landscape. But the big thing that I want to encourage you all to do is just go and start building these software bill of materials files without fear. The automation that exists from places like GitHub is quite good. You can rely on it. You can build that into your process, and then go and build out the storage and cataloging and all of the other capabilities that you need to make the program actually make sense over time. With that, that is all the content I had to produce. But I am happy to answer any questions folks might have about how to make the most of SBOMs in your environment or how we've done things at GitHub.
Much appreciated, Justin. Thank you so much. Great. I think Very interesting insights, very good practical advice. It's really the type of things that we were looking for. I'm looking around here a bit in the audience, if there's any questions, and also online from people attending. I'd say in the first reaction from my side, let me sit down here. But I'm sitting on my knees for you. Can you imagine?
Don't hurt yourself.
That's fine. Is the what do you see in terms of the consumability of the SBOMs? You've talked a lot about the producing part of it. The results being exported into VEX and the more mature SBOM generators publishing in VEX also. But can you also see the actual usage of the SBOMs by the end consumers?
So far, I would say most of the organizations that are asking for SBOMs because they mean to consume them have no idea what they mean to do with them, quite literally. And so, there's the cataloging problem for producers, but there's also one for consumers. And, I think this is a niche where the industry hasn't yet risen to the opportunity to create good solutions for cataloging SBOMs on software you've purchased. And so we've seen that sort of wide scale where, people have the intent of doing the right thing with them, but nobody really has mature processes around it today.
Yeah, I think we see the same things here. The most useful application that I've seen was really the integration of some of the SBOMs of some of the tool vendors being directly integrated into the security operations centers, incident management teams.
Yep.
That also know how to deal with the vulnerabilities that are being exposed to them. And they also already have a process where they can manage vulnerabilities. So that was the most straightforward one.
Yeah.
Okay. Any questions from the audience here?
I
Yes.
have a question about provenance. I don't know if it's actually your cup of tea. So if I'm mistaken, you can safely say it's not my cup of tea. But when we're taking a look at signing software and signing packages more specifically, I was wondering if you have any opinion on how the way APT does it. Maybe they don't sign packages, but they just verify the upload to the signature, and then trust is in the registry rather than in the packages on that registry. Do you know if that could potentially lead to some problems?
I'm not sure if you get the question, Justin, because it's maybe a bit distant.
Yeah, it was too hard to hear, but yeah, I'd be happy for a repeat.
Okay, so I'll try to repeat it. Otherwise, you can come over here. That's fine too. It was on provenance, and Chris wasn't sure whether you would be able to answer the question, but yeah, go ahead.
Yeah, if it's not your cup of tea, you can just say so. But I was talking about APT registries and how they deal with signing. It's not like the packages are signed, but rather they verify the upload, and then there's trust in the registry itself, and then you can download those packages. And I was wondering if you had any opinion on that kind of system, and if it's better to have signed packages to start with.
So I don't have experience with APT specifically, but in general, one of the challenges we see with registry signed packages is you still can't repudiate that the owner was correct. And so you talked about how, there's testing that happens on the registry side itself. And that's an okay thing. So, that sort of central signing service is kind of the story that you see from like the App Store or the Google Play Store, where there's centrally signed packages. And we also see this for like drivers in operating systems. And so those centrally signed packages that are using a trusted root cert, you kind of have to depend on some level of understanding who the author was, and the level of confidence you have in the package should be proportionate to how good the identity validation is for the person that uploaded it, and then how good the validation of the software is. In a limited domain, where you kind of understand what these things are supposed to do and they have limited capabilities, you're usually probably fine. Certainly like your app store kind of capabilities, centralized signing works well. I think everybody feels pretty good about installing an app from, on their iPhone. But for pieces of software that are sort of more arbitrary, or their developer packages, the ability to test those is pretty limited in my experience. We have seen some pretty sneaky malware out there that actually is designed to have different behaviors when it's in a test harness than when it's on customer machines. So they've done some things where they've actually looked at IP blocks where the testing takes place, and they've actually got different behaviors when they're in test machines than when they're on customer machines. And that's been really sneaky and difficult to deal with. So the best kind of signing is, of course, signing that happens end to end, where you can validate all the way back to the source code, where it came from, the provenance on every step. Signing on the registry side is better than unsigned code, to be clear. I'm not trying to say that registry signed software is bad, but it is not quite as much of a security guarantee as end-to-end signed provenance.
Okay, that's a great answer. Thank you very much. I may have a question, if I still may. Yeah, if we would have a private registry, do you think it would be useful to have developers sign their own software towards that private registry before it's packaged and sent to the outside world, so to speak? Or do you think that's only a very small and limited way of attacking the system that would be possible that way?
I mean, in general, I think it's a good idea for folks to start looking at signing and provenance for all of their software. Ultimately, whether it's consumed internally or consumed externally, you want to be able to provide those guarantees to your customers that it is authentic. If you're delivering, software where it's SaaS software, it's all hosted in your cloud, your website, or what have you, maybe that's not as important. But certainly if you're producing downloadable software that the customer has to use and verify, providing those signatures and information on how to verify that the software is authentic is not a bad thing to do. It gives your customers assurances, not just that the software is signed, but also that you have a rigorous process that they can trust. Because ultimately, sometimes you use those processes as a way to establish the maturity of the folks that are building the software in general. If you haven't already, I would definitely encourage you to have a look at the SALSA process. This is the security levels for software artifacts spec, and it describes a maturity model for producing, signing, and distributing artifacts that I think everybody should have a look at for additional information on exactly what are the best practices from industry security leaders.
Okay, that's a great pointer. Thank you very much.
Okay. Other question?
Just the fact that this SALSA was something that was mentioned in the emails, would like have a look at, because it's something that might be useful.
Oh, okay.
In terms of SBOM.
Okay, confirmation on SALSA. So we're gonna have a dance tonight, it seems. Or some hot sauce, whatever. Okay. Any other questions? Justin, I think you are clear to really continue with your day today, or to start your day. Thank you very much for the intervention. I think people will have been wasted here, or basically have had the luck to get so many inputs that it's probably a little bit information overload by now. But we have your contact details, and if you allow us, then we'll be happy to reach out to you if there's anything further. And if you would like to contact us, for some other cases or reconnections on European sites, please don't hesitate to do so. We will be having a conversation with the Commission in February or March timeframe in this forum. They will also participate directly, and so we'll have a much more in-depth discussion also on the developments, and maybe you can join in there at the time as well.
Be lovely. All right, Ulrich, thank you so much for bringing me along, and everyone in the room, thanks for tuning in, and hope this was great.
Absolutely. Thank you.
Thanks all.
Okay, so shall we call it a day?
I think so.
Yeah. All right. Dear ladies and gentlemen online, we're going to call it a day. And so we thank you also very much for your participation and interest and sticking around the whole day, more or less. And thanks also for some of the reactions that you posted on the chat. Seemed that people were still very much following somehow, probably also doing other stuff. Anyways, we'll have our next IIoTSBOM development, and yeah, we do. Thank you very much. Yeah, thanks, Ludo. So we'll probably have a next session in a couple of weeks' time. Only purely webinar again in this case, than the hybrid format, and yeah, we'll be focusing again on some of the tooling and then also some of the end user developments, how they are actually using the SBOMs, contrary to maybe what Justin was just mentioning. So for all of those of you online, stay connected, and we'll see each other again in a couple of weeks' time. And we're going to have a beer here. So too bad for you guys. Bye.